Hi customers, just wanted to do another video over a subject that I see a lot that I find is commonly misinstalled. When we're doing tear-offs, we don't see that enough is installed for code compliance in this area. So the title of the video is, what does code compliance mean and did you ask? So I hear some people say, well, yeah, we installed a code. And yeah, we install that. So yeah, we install a code. Today's video is going to be about ice and water barrier. But let's say that it's, oh yeah, we install the shingles. Well, we all know that shingles can be installed wrong. So just like shingles can be installed wrong or flashing can be installed wrong, so can other materials like ice and water barrier. It is required by code in this climate zone. And we can be glad to show you guys those codes because I've had argument about that. And today I want to show you a common misconception. So going through, we're in Ursa today, but this material right here is ice and water, this black stuff. So a lot of people think that might be organic felt paper. That is not organic felt paper. That's ice and water barrier. It seals down. So the roof you see, I can't get it peeled up. And then that up there is synthetic felt. So the black stuff is ice and water barrier, gray stuff is synthetic felt. And what commonly happens is that we don't install enough. So it comes in 36-inch rolls, and commonly we see 36 inches installed at the eave. Well, ice and water barrier is required by code. In this climate zone, we install it in some areas that aren't required, so like valleys and step flashing, but the main concern is at the eaves. And the code is 24 inches inside the conditioned space from the lowest parts of the roof slope. So the lowest parts of the roof slope is the eave, and we're supposed to install it in a length where it exceeds 24 inches inside the exterior, or inside the interior, so inside the conditioned space. So I drew a few different diagrams here so you can see that this isn't just a guess or a one-size-fits-all for all roofs. Now you can put practices in place like we have to make sure that you cover it in most situations what code is, and then you can manage past those unique situations where you need a little bit more. So I just want to go over that with you guys. So this is kind of our base diagram, and you'll see here that I have a roof slope. This is the eave measurement. So like this is where your soffit would be. Your gutter would be over here. You'd have the soffit here. This is the wall. This is the interior wall, the interior edge. And then the thing that is constant is 24 inches. You're required to have 24 inches inside the exterior wall. So you can see that the measurement from here to here is longer when you go this way. And it's also the hypotenuse for you math people out there. So this is the hypotenuse. It's always going to be longer than what this is to this is. And I promise this line makes a big difference. Okay, so let's look down here. So on this style roof, and it's actually this roof I'm drawing for the roof that we're working on today, I have a few variables that change with each roof based on the uniqueness of the roof. So we have an 812 pitch here. That's a 33.69 degree angle. So that's that one, because we use a right triangle calculator. We don't go through the whole math equation of figuring sine, cosine, and tangent to figure out the lengths. We just type it in our right calculator. We only have to have two measurements. We got to have the degree measurement, and then we have to have our known measurements. So what we know is that on this roof, this is a 17-inch eave. We know that this is a brick home. It's about 12-inch wall space. Okay, so 17 plus 12. And then we also know that the code requires us to install it from the lowest portions of the roof slope to 24 inches inside the exterior space. So inside the conditioned space. So this is the interior portion of the exterior wall. We got to be 24 inches inside of that. So we know that this base of this right triangle, because here's our right triangle degree. We got 17 plus 12 plus 24. That equals 53 inches. So 53 inches is this distance from here all the way to here. When we put that into our right triangle calculator, we get that the hypotenuse is 63.7 inches. So that's the amount of ice and water barrier that would be required to bring this home to code. So on this roof, on this roof, we have 2 rows. It comes in 36-inch rows. So let's do a little measurement here. Oop. A little windy. So with the overlap, we're at 66 inches. Almost. Not quite enough code. Almost. Come down to the 64. That's where the code's requiring. Just enough. 2 rows of ice and water barrier. Not 1 row. 2 rows on an 812 pitch. Almost didn't get there, right? On this home, an 812 pitch is nothing unique. It does get a little steeper, but this isn't something that is that unique out there. And this home requires 17-inch eaves. That's not that uncommon. So this would require 2 rows of ice and water barrier and almost a little bit more than that, almost 3 rows, right? So let's use a different equation. So let's say that this is more of a standard deal, and let's say that the eaves are only 6 inches. Let's say that it's 2x4 construction, and let's say that it's only got 6-inch walls. And then let's say the code doesn't change, so it's 24 inches. And let's say the pitch is a real standard pitch. There's a lot of 412 homes in Quincy, Hannibal area that we've worked on. Ranch style homes, single-story ranch style homes, a lot of 412 pitches. So, but most of those have longer eaves than 6 inches. But let's look at this diagram. So now we're looking at this one. And here again, we have a 6-inch eave. We have the 2x4 construction. So let's just assume that that's 6 inches. It's probably a little bit more than that, but let's just say 6 inches. And then we have 24 inches. That never changes. So the base of this right triangle is 36 inches, right? 12 plus 24 is 36. So on a 412 roof pitch, that's 18.4 degrees. We type this and this into our right triangle calculator, and we get the hypotenuse is supposed to be 37.94, so almost 38 inches. Well, wait a minute. I just told you that this material is 36 inches without the overlap. So 36 inches is what 1 row of ice and water barrier is. So even in a situation where we have a very tiny eave and we have a very tiny wall space, we're required to have a minimum, unless you're cutting your roll down, which is a lot of labor, we're required to have a minimum of 2 rows on 90% of the residential structures out there to meet the minimum for code requirements. So when you have a contractor that says, yeah, we installed a code, we install ice and water barrier, what does that mean? How much ice and water barrier? When they say we installed a code, yeah, we'll correct the ventilation. How is it deficient now? How are you going to make it correct? What does code mean? So that's a question that you should be asking your contractor. If you would like to talk with us about how code complies with your house, if you're currently in compliance, if you're thinking about a roof replacement and just want to get the scope of what needs to happen to bring it to code and per manufacturer instructions, you can certainly visit our website and go to the free quote page. That's rightrateroofing.com, grammatically correct. Or you can call the office at 217-779-7663. Thanks. Have a good day.